Welcome back. In this episode, we will discuss about the some modular arithmetic formulas and some problems we will see. Then onwards, we will go through the relative prime if time permits. Okay. Then first we will see modular arithmetic. So here, in the examination point of view, we will ask the questions some formulas, maybe a plus b model. So this can be written as a model plus b model whole model. Similarly, if you want to create A minus B model equals to A model minus B model, and this is model. Okay. Another problem is AB model. AB model can be written as A model into B model whole model. Okay. So this is another formula. And we have the modular exponentiation rule, that is a power b model. A power b model. Okay, if you write like this, a into a into a into a into up to model, up to n times, we need to write model. Okay, so this can be written as a square model into a square model. Like that, it goes on. Finally, model will be applied to the entire formula. Or else you can apply a power 3 model, depending on the functionality we can use a power 2 or a power 3. Okay. So finally, sometimes we will get a power b model is equals to 1. So that is third formula. And some properties are there. So that is properties are a plus b model equals to b plus a model. Okay, this is one formula. Similarly, AB model equals to BA model. AB model equals to BA model. This law is a commutative law. And the second property is associative law. A plus B plus C model equals to A plus B plus C model. Okay. Similarly, we can apply A into B into C model equals to A into B into C model. So this law is associative law. Similarly, another law is uh, A into B plus C model can be written as A into B model plus A into C model. Okay, this is associative law, distributive law. This is a distributive law. Okay, finally, identity law. So identity law is 0 plus A model equals to A mod A plus 0 plus A equals to A mod n. Okay, this is identity law, as well as 1 plus as well as 1 into A mod n equals to A mod n. Okay, and another formula is the additive inverse. So A plus minus A is equals to 0. So A plus A minus A mod n equals to 0, that is called additive inverse. And we have another formula that sixth a into a inverse equals to 1. That is a multiplicative inverse. Multiplicative inverse. Okay, these are the formulas. Now we will observe and solve a one by one problem. A plus B modern. So A plus B modern means you can write as 6 plus 1 mod n can be written as 6 mod n. N is you can use 8, or you can use 5. You can use 5. 6 plus 1, 7 mod 5. Okay, 6 mod 5 plus 1 mod 5. Okay, 6 mod 5 means 6 mod 5 means 5 divided by 6. 1 5 is 5, remainder is 1. So this value is 1. 6 mod 5 value is 1. And 1 mod 5. So 5, 1 means 500, remainder is 1. 1 mod 5 is 1. So 1 plus 1 is equals to 2. So if you observe 7 mod 5 means 5 divided by 7, 1 5 is 5, remainder is 2. Right? So here left hand side we get the 2, right hand side also after applying the formula we get the 2. Okay, so this is the answer. If you want to apply again mod n, 2 mod 5, 2 mod 5, 5 divided by 2, 500, remainder is 2. Okay, so this is the final answer. AB mod n, take the same value. So 6 into 1 mod 5. 6 mod 5. So what is the value of 6 mod 5? What is the value of 6 mod 5? 6 into 1 6 mod 5. 5 divided by 6. 5 ones are 5. Remainder is 1. So 6 mod 5 is 1 actually. Okay. Now here observe here. A mod n means 6 mod 5 and 1 mod 5. Okay, what is the answer? 6 mod 5. It is already we know 1. 1 mod 5. 5 divided by 1. 500, remainder is 1. So this is also 1. 1 into 1. 1. 1 mod, again mod 5 here. Mod n means mod 5. So 1 mod 5 means 5 divided by 1, remainder is 1. Okay. So here also we get the 1, and here also right hand side also we get the 1. Okay. Like that we can prove the properties of modular arithmetic. Here simple. Now you take A is a 6, B is a 5 mod 5. Okay. Or else a simple problem. 3 power 5 mod 5. A is 3, B is 5, mod 5. Okay, this can be written as A into A into A into means 3 into 3 into 3 into 3 into 3, 5 times 1, 2, 3, 4, 5, 5 mod 5. Right? So this can be written as 3 into 3 square into 3 square into 3 mod 5. Right? So for the sake of understanding, if I am writing, so no problem. So 3 mod 3 square mod 5 means 9 mod 5. So it is a 9 mod 5. Okay, if you observe the formula A B C mod n, A mod n, B mod n, C mod n. So 9 mod 5. This is one. Another is 9 mod 5, and finally 3 mod 5. Right? So 9 mod 5 means 5 divided by 9. 5 ones are 5, remainder is 4. So this value is 4. Also this value is 4. 5, 3 mod 5 means 5 divided with 3. So 5 zeros 0, remainder is 3. So this value is 3. So 4 into 4, 16. 16 into 3, 48. So this value is 48. Okay. So 3 power 5 mod 5 can be identified as 48. So for example, if you have 3 power 5 mod 8, what will be? So 3 power 5 means 3 square 3 square into 3 square into 3 power 1. okay, into mod 8. So this is 3 square mod 8 and 3 square mod 8, another one is 3 power 1 mod 8. Okay, so 3 square mod 8 means 9 mod 8. So if you divide 8 with 9, 8 1 j 8, remainder is 1. So this is 1. Also this is 1. So 3 power 8 mod 3 means 8, if you 8 divided by 3, 800, remainder is 3, this is 3. So less than number, less than n value, less than value if you find, so the same number will come. 1 into 1 into 3. So answer is 3. Like that you can find the a power b modern modular. This is addition, modular addition. This is a modular multiplication. This is modular exponentiation. Okay, so these are the practical values you can obtain with the help of the formulas. So formulas are useful to solve the problems. Okay, so this is 1, 2, 3. This is 1 and this is 2. Okay, so similarly properties are there. A plus b modern is equals to b plus a modern. AB modern is equals to b a modern. The commutative A plus b plus c modern is equals to a plus b plus c modern. So all the stuffs are pretty common. Okay, and coming to this very important and somewhat useful instruction here is a plus minus a modern means let us take a is equals to 2 plus minus 2 modern mod some 2. So this value may be 2 plus minus 2 means the additive inverse is minus 2 here. So the additive inverse of 2 is nothing but minus 2. Additive inverse of 2 is nothing but minus 2. Additive inverse of minus 2 is nothing but a 2. Okay. If you do this automatically 2 plus minus 2 nothing but a 0. So we will get the 0 value. Okay. So this is additive inverse. Multiplicative inverse is very simple. Multiplicative inverse means suppose 3 something into something equals to 1 mod uh, 10, 1 mod 8, 1 mod 8. Suppose if I write here x equals to 9, 3 into 3 equals to 1 mod 8. So 3 into 3 means 9. 9 equals to 1 mod 8. 1 mod 8. So this can be written as 9 mod 8 equals to 1. So whether it is right or not, let them see. 8 divided by 9, 8 1 j 8, remainder is 1. So 9 mod 8 is equals to 1. So the multiplicative inverse of the 3 is nothing but a 3. Okay. Also you can use another also you can use another method. In the later videos we will see what is multiplicative inverse elaborately. So at this moment of time you can understand the multiplicative inverse of 3 is a 3 here, because what value is to be multiplied with the 3, then only we will get the remainder is 1 for the modulo n, right? That is the multiplicative inverse. Okay. So next we will see the relative primes and primitive roots. So what is primitive roots and relative primes? In the next class we will see. Uh, Now we will see relative primes and primitive roots. What is the relative prime number and what is the uh, primitive root. Next one is relative prime numbers. Relative prime numbers. So this is very simple to understand. Relative prime numbers means if you find GCD A comma B, if you get only one, means let us consider GCD 3 comma 11. For 3 only we have factors 1 comma 3. For 11 we have the factors 1 comma 11. If you find only one factor is common, that is 1, except remaining factors. All factors are irrelevant, but only one is the common factor. If you have the one is the common factor for any two numbers or any three numbers or any numbers, then it is called relative prime numbers. So A and B are the relative prime numbers under modulo n. Under modulo n. Okay. So this is relative prime numbers. Like another example, you can write 7, 17. You couldn't find any common factors here except 1. So 1 and 7 are the common factors here. Here 1 and 17 are the only factors we have. So GCD 7, 17 is equals to 1. So plenty of examples you can find where the common factor is only 1 except other numbers. Then it is called a relative prime number. Next one is primitive roots. What is the primitive root? Primitive root is also very important. Primitive roots means if I have mm, write 3 is a primitive root of if is 3 is a 3 as a primitive root of primitive root of 7. If the question asked like this, if 3 is the 3 primitive root of 7, is the 3 primitive root of 7, and in any time a question asked like this, I need to write as 3 power 1 mod 7. Similarly 3 power 2 mod 7 up to 3 power 6 you need to write 3 power 4 mod 7, 3 power 5 mod 7, 3 power 6 mod 7. So below less than 7 you need to write. So now 3 mod 7 means 7 3. So 3700 remainder is 3. So if the number is below this value, right side, if the number is below the 7, then that is the direct answer. Here 9 7. So 7 and 9, 7 1 just 7, remainder is 2. So here remainder is 2. Okay. Now 3 power 3 mod 7 means 727. Okay, 7 4s are 28, remainder is 1. Okay, 3 power 4 means 3 power 2 into 3 power 2 means 9 into 9, 81. So 81 means 7 and 81. 7 and 7, 11, 77, 7, 12 are 12, 12 sevens, and 7 to the 4, 14, 84. 84. 8, 84 is bigger. So 12, 7 11s. So 7 11s means 77. So 4 plus 1 5. So 5 is the answer. And 3 power 5. So 3 power 4 is 81. 3 power 5 means 81 into 3. Uh, 81 into 3. So 3 into 1 3. 8 3 are 24. So 243 mod 7 means 7. 7 3s are 21, and this is 3 3. 7 4 7 4s are 28. Remainder is 5 here. So this also is a 5. 3 power 5 is 5. 3 power 4 3 power 4 81. 3 power 7. Okay. So here I need to check this one. This is okay. 9 mod 7 okay. 3 power 3. 9 into 3 27. 27 mod 7. 27. 7 3s are 7 4s are 28. 7 4s are 28. So 7 3s are 21. So remainder is 6. Here 3 power 3 mod 7. Remainder is 6. I wrongly written here. Okay. And 3 power 4 means 3 power 3 is 27. 3 power 3 is 27 into 3. 7 3s are 21. 2. 3 2s are 6 into 2, 81. So 81 mod 7. 81 mod 7 means 7 into 81. 7 7 7 10 7 11 are 77. Okay, this value will get 5. Okay, So 3 power 4 mod 7 is 5. 81 mod 7. This is 4, sorry. 81 minus 77, 4. So this value is 4. Okay. And 3 power 5 mod 7. 3 power 5 mod 7. 3 power 5 means 3 power 4 means 81. So 3 power 5 means 81 into 3. 3, 8 into 4, 243. So 243 mod 7 means you need to divide with the 7. So 7 3s are 21, 3, 3, 7 4s are 28. This answer is 5. So this is okay. 3 power 6. So 3 power 6 mod 7, if you get, you can write as 3 power 2 mod 7 into 3 power 2 mod 7, exponential rule. 3 power 2 mod 7. So 9 mod 7 is equals to 2. Here we get. This is also we get to 2. Here also we will get to 2. So 2 into 2 4, 4 into 2 8. So after finding all the mods below the 7, if the number is repeated, then 3 is not a primitive root of 7. Here if you find 3, 2, 6, 4, 5, all the numbers are in individual numbers, so it will not repeat. No repetition. No repetition of numbers. So 3 is a relative primitive root of 7. So that is called yes. Okay. Like that you can write the primitive roots. అలాగే వస్తున్నా రాదు పర్లేదు. Now if I am asking question, if 2 is a primitive root of 5, if the question asked like this, 2 power 1 mod 5, 2 power 2 mod 5, 2 power 3 mod 5, 2 power 4 mod 5, you need to calculate. So if the number is below the 5, then automatically answer is 2. 4 mod 5, answer is 4. Okay, if you do the same, 5 4, 5 zeros 4, remainder is 4, right? And the 2 power 3 means 8 mod 5. So 5 into 5 divided by 8, 5 1 is 5, remainder is 3. So here this value is 3. 2 power 4 means 16, 16 mod 5 means 5 divided by 16, 5 3s are 15, remainder is 1. So this value is 1. So if you observe here, no number is repeated here. So if no number is repeated, then that number is relative, then 2 is a relative prime number, then 2 is a primitive root of 5. So is it primitive root of is it 2 is a primitive root of 5? If question asked, then it is yes. If in any case roots are appeared twice or something like that, then it will be not the answer. So if the repetition happened, 2 is not a primitive root of 5, you said like that, right? So this way we can identify the primitive roots as well as the relative prime numbers as well as the modular arithmetic roots also you can do. From this video alone, you can identify number of things. Okay. This I hope this video will help you a lot. If you find helpful, then please subscribe, share, and comment on this video. Thank you very much. See you. Bye bye.